The northern and southern lights, also known as the aurora borealis and aurora australis respectively, occur when high-energy particles from the sun collide with natural atoms in our atmosphere. The energy emitted from this crash produces a spectacle of light that mankind has marveled at for centuries. But the particles' journey isn't just as simple as leaving the sun and arriving on the earth. Like any cross-country road trip, there's a big detour, and nobody asks for the directions. Let's track this intergalactic voyage by focusing on three main points of their journey: leaving the sun, making a pit stop in the Earth's magnetic fields, and arriving at the atmosphere above our heads.
The protons and electrons creating the northern lights depart from the sun's corona. The corona is the outermost layer of the sun's atmosphere and is one of the hottest regions. Its intense heat causes the sun's hydrogen and helium atoms to vibrate and share off protons and electrons, as if they were stripping off layers on a hot sunny day. Impatient and finally behind the wheel, these free protons and electrons move too fast to be contained by the sun's gravity and group together as plasma and electrically charged gas. They travel away from the sun as constant gale of plasma, known as the solar wind.
However, the Earth prevents the solar wind from traveling straight into the planet by setting up a detour, the magnetosphere. The magnetosphere is formed by the Earth's magnetic currents and shields our planet from the solar winds by sending out the particles around the Earth. Their opportunity to continue the journey down to the atmosphere comes when the magnetosphere is overwhelmed by a new wave of travelers. This event is coronal mass ejections, and it occurs when the sun shoots out a massive ball of plasma into the solar wind.
When one of these coronal mass ejections collides with Earth, it overpowers the magnetic sphere and creates a magnetic storm. The heavy storm stretches the magnetic sphere until it suddenly snaps back like an overstretched elastic band, flinging some of the dotted particles toward Earth. The electric band of the magnetic field drags them down to the aurora ovals, which are the location of the northern and southern light.
After traveling 93 million miles across the galaxy, the sun's particles finally produce their dazzling light show. With the help of some friends, 20 to 200 miles above the surface, the electrons and protons meet up with oxygen and nitrogen atoms, and they sure are happy to see each other. The sun's particles high-five the atoms, giving their energy to the Earth's neutral oxygen and nitrogen atoms. When the atoms in the atmosphere are contacted by the particles, they get excited and emit photons. Photons are small bursts of energy in the form of light.
The colors that appear in the sky depend on the wavelength of the atom's photon. Excited oxygen atoms are responsible for the green and red color, whereas excited nitrogen atoms produce blue and deep red hues. The collection of these interactions is what creates the northern and southern lights.